So far, we've seen two very simple circuits, the voltage follower and the inverting amplifier. Now, sometimes it would be helpful to have a non-inverting amplifier, and this can be realized with the same number of components as the inverting amplifier, except that there is one restriction on the gain of this amplifier. The circuit is shown here, and it looks very much like the inverting amplifier, except that R1 is connected to ground instead of to the input, and the input is connected to the non-inverting input of the op-amp. Now, we have negative feedback, therefore the op-amp will do what it must in order to make the voltage at the inverting input equal to the voltage at the non-inverting input. So the voltage between the two resistors is Vn. So let's see what we've got here. We've got Vn right there between the two resistors. So we've got Vn across R1. Since the other end of R1 is grounded, so we have a current flowing to the left, and the magnitude of that current is Vn divided by R1. Now that current cannot come out of the input of the op-amp. Remember our assumption that there is no current into or out of the inputs of the op-amp. Therefore, all of that current must go through R sub F. Therefore, the voltage across R sub F, with the positive reference on the right this time, is Vn times Rf over R1. Now, this looks very, very similar to what we had when we were looking at the inverting amplifier. Big difference here, however, is that instead of having a virtual ground between those two resistors, we've got a virtual Vn. Now, if you apply Kirchhoff's voltage law from the output terminal through the resistors back to ground, you've got Vout is equal to Vn times Rf over R1 plus Vn. If you simplify that, you end up with Vout is equal to Vn times 1 plus Rf over R1. Now, since real resistors are always positive, you cannot have a negative value there for that resistor ratio. Therefore, you cannot achieve with this circuit an amplification less than 1. And if you wanted an amplification of 1, you'd just use voltage follower. So, what do we do if we need a non-inverting amplifier with a gain less than 1? Oh dear. Well, one thing you could do would be to put two inverting amplifiers in series to achieve a gain less than 1 that's non-inverting. But we can also do this with a single op-amp and two resistors. In this case, we simply connect a voltage follower, but to the input of the voltage follower, we connect a voltage divider. So Vn then goes into the voltage divider of R1 over R2. So the voltage at the non-inverting input is now R2 divided by the sum of R1 and R2 times Vn. So you can make that arbitrarily small, or you can make it arbitrarily as close to 1 as you wish. Now, this still has one problem that the inverting amplifier does not have. With the inverting amplifier, if you were to make one of the two resistors a variable resistor, and say connect it up to a knob, you can actually turn that knob, change the variable resistance, and you can change the gain from less than 1 to greater than 1 just by turning that knob. With this circuit or with the other circuit, you cannot do that. You can make one of the resistors variable, but in this case, you can only vary the value from some very small value up close to 1, or in the other circuit, the basic non-inverting amplifier circuit, if you make one of those resistors variable, then you can only vary it between 1 and some larger value. You can't adjust it so that it will go to both sides of 1, a gain of 1, by simply turning a knob or adjusting a variable resistor. Now, you could combine the two circuits. You could put a voltage divider on the input of this circuit, and then you could, for example, make RF a variable resistor, adjust the voltage divider so you had whatever minimum gain you wanted there, and then you could adjust R sub F to give you a gain that would go down to whatever that voltage divider value specified at the non-inverting input, and then up to whatever the gain factor was based on R sub F. So you could do it, but that would require 4 resistors, not just 2.